Introduction to Calculating Compound Interest, presented by Doug Bainbridge. The variables involved are the principal or original balance and the interest rate. For this initial example, we will assume a fixed rate. The basic equation is described as follows. The equations involved can look quite complicated depending on what you hope to calculate. For now, I will cover the basic concept. With compound interest, you are paying interest on the interest and the principal and continuing to do so as time passes. You can imagine why you would want to be a recipient in such an arrangement as opposed to the payer. For each compounding period, this is the calculation. Assume the following variables. P will equal principal from the previous compounding period. I is the interest rate fixed for my example. NP will be new principal for current compounding period. The equation is NP, or new principal, equals principal from previous compounding period times the interest rate plus the principal from the previous compounding period. In other words, you're adding the interest onto the principal to be used in the subsequent calculations. Let's look at how fast the money can double. In order to double the principal in one compounding period, the interest rate must be 100%. That is, 100% will be the interest rate for the principal to double in one compounding period. Here's the calculation assuming the original principal is $100 and the interest rate equals 100%. See where we start off with the original equation. New principal equals principal times interest plus principal, including the numbers now, $100 times 100% plus $100, $100 times 1 plus $100, and therefore we have $100 plus $100, which equals $200, therefore doubling the principal in one compounding period. What happens at different interest rates? For the following examples, we will look at the numbers in a spreadsheet format so we can see how they look for each compounding period. If the interest rate is 50%, it takes 2 compounding periods to double the original principal. See in the first column, principal, we start with $100 and the interest rate is 50%. Moving across, the compounding period, of course, this is our first compounding period. Interest in that case is $50. The new principal is $150. Moving down to the next row, we see where we take our $150. That's what we're using for the calculation for the second compounding period at 50%. The interest in this case is now $75. And the new principal is $225. Therefore, we have taken 2 compounding periods to more than double the original principal. What happens at different interest rates? If the interest rate is 25%, it takes 4 compounding periods for the principal to be more than double the original amount. See below, where starting with $100 in the first compounding period, we end up with the new principal in the fourth compounding period being $244.14. Below this, notice if the interest rate is 10%, it takes 8 compounding periods to more than double the original principal. See below where we start with $100, compounding period 1, and at the end of doing the compounding in year 8, we end up at $214.36. Now to continue, if the interest rate is 5%, it takes 15 compounding periods to more than double the original principal. See where in year 1, start with $100 principal, and in year 15, at 5% interest, we have a new principal of $207.89. So it took that long at 5% to double, a little more than double, the original principal. Conclusion: compound interest can be a useful tool if you are paying or receiving payments. As you can see by the examples, the money can accumulate rather quickly, so especially with any loan arrangement that utilizes compound interest, make certain to be aware of how repayment is calculated. I hope you found this helpful, and I wish you a great day. Again, this was presented by Doug Bainbridge.